Guys, in this video, gonna talk about set theory. So, why we like, why haven't we started with asymptotic analysis or anything? If you remember, if you have watched the last video, I don't know how many of you, but what we are doing here is not getting into the details of the mathematics, but what we are trying to do is to kind of link and trying to answering the whys, because a lot of time I've been wonder like why our AND gate came, like from where it came from. I like so many whys from my college days, even I think a little bit from the school days, but I wouldn't be able to find those answers at those times. So I'm kind of, doing this thing is just recording this thing. How do I study by myself? So it's just a video format, and that's how usually I study. So in set theory, what basically a set means, because it's the word which you're gonna see a lot in upcoming part of the programming. The set basically means a collection. How you gonna understand a collection? I mean, you kind of get an idea what collection is. You can think of the money in your wallet that you have organized, maybe unorganized way, but like it's a collection. That's it. But how are you gonna correlate it with computers, and how it is going to be like a little bit of understanding, how you're gonna make understanding around it. So you can think of this like, for example, my keyboard. I just put this example in my last Hindi video. So if you can look at here, you can see like, so that's my keyboard is. And if you look like really carefully, what this is the collection of the keys. Okay, and what happening here is that each key is kind of have its own identity here. And if you kind of look that, it's a collection. Your system is a collection, and that's what it is. So with each and every key, what is happening is you kind of have association. What I mean by that is when you press a key I, it's gonna show you I. That's a very important thing. And if you remember very thing, like if you remember very thing, like let's hop to the display here. In the last part, what we have done is with set theory, before set theory, just leave it. So before set theory, I think what we have done is a proposition logic. And over there, if you remember that we have represented those statements as PQRST as an example, and shape like really quickly around it so that you gotta know CB. Oh no, it's the wait. Let me put you down again. It's the last video which I like did a little bit earlier here. So let me just make a new shape again. This thing. Okay. So if you remember what we have done in our last part is we had like logics. We have our problem statements which we have made them into like really complex part. What Why? Because so that we can be able to, so we can be able to achieve to a solution, to an answer, to a truth value, or could be true or false. That doesn't matter. But what we have done is we have made a collection of statements. That's a really important thing. With all those connectivities, and or maybe the all the other connectivities which we had, we kind of have made the collection, and we had an output. And that's just not the very only problem. We have like multiple problems over there, and we have multiple truth values over here. So here, if you remember, like let's try to represent the output as x, maybe y, maybe z, maybe zz, maybe yz, anything like that. Could be any variable name. So what happening was there is kind of it's a collection of logic or the statements. And here what we are having is the proofs which we were deriving, or the truth values which were arriving after having this. So we're not only limited, let's see, in maths we are not just collecting and making things at one place, organizing, unorganizing, whatever doing. Like we are not just limited by these collections. We were doing something. We were getting an output of it, out of these statements. We were getting something out of it, and this thing right here is known as mapping. This is a really important thing, because it's being like really 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 important when we're gonna teach, we're gonna understand what programming is. And this is also known as function, and this is a very important word. Okay, so what was happening here is that we kind of having our mappings going on to the outputs, and that's a really important thing to understand at the very first thing about set theory and functions. And if you kind of remember that we, in our proposition logic part, we had like kind of done the same thing. Here we just kind of representing it in a different way, and that is something. So how we are going to understand this a little bit more with computers. So if you remember that I have put an example right here is the collection of things. See these keyboard. So when I press I, it's gonna send a signal to the computer and it's gonna show you I. That's what mapping is, because this I is being mapped to that I. It's not gonna be happen like if you press I mean if your keyboard is like becomes a buggy. Sometimes what happens, you press a single I, it kind of start entering two or three or four eyes all together, maybe not working at together, because it just got malfunction. But the function is supposed to put an I. That's the truth value of it. If you press I, it shows you I. And that's what a function is. So you can now think of everything as this as a function. Here, the keyboard itself, well, which is by the way a collection. Now you're gonna be calling me like, what are you doing? So you can think of these as kind of function in a way, where what is happening between these two guys is that you kind of have one part of this keyboard. Like let me show you on this. So you kind of think of this as like this is the keyboard, and here like bunch of keys, and here is I, and you can think of this as a display right here, and my monitor actually kind of looks like the same, and here you present the I. So this kind dude is kind of linked and mapped. That's what a function is. Okay, that's what a function is doing. That's it. That's what a function is. And this is a very important concept, because you're gonna see a little bit more of a complexity kind of thing here which is going to happen. And let me read through my notes. Okay, so this is a very yeah, okay. So now for for example, take the example of a friend. You said to your friend, show me I, if you like on the desktop or not, like what could be the possibility or the probability that a friend are gonna like show I, if you can imagine your friend could shows himself or herself that this is the I, this is me, and you be like, no, I didn't ask, because you were not a little bit clear about which I you're talking about. And that's where this kind of important a kind of operator kind of thing, since we remember, you remember that we kind of have seen operators in in proposition logic, these like and, or, and not. Same thing goes here. So how you know, so for example, let's name this as capital key in capital K and capital D for display and for keyboard. In our set theory, we represent this complete bigger set as with capital letter, and inside of the kind of represent with small alphabets, it depends. So we kind of represent this thing with this. So I belongs to this K. Here this I belongs to this D, which is kind of mapped with a function, so that the problem of not being able to understand from where it came from, what it is, kind of doesn't make confuse other people. And that's a really important thing. Now coming up to this a little bit, next section of it is kind of representing this set, and how can we like show the very common method of showing a set. For example, take a set of vowels in English alphabet. So that could be A, E, I, O, U. That's oh god, no. We cannot present by. So that's your vowel, that's a set of vowel. Okay, and this is basically called a roster method. I kind of use it like quite a lot, and this very common in programming when we're gonna see it. So this is a really common method. Then there is another method of representing set, and that's called a, let me, oh sorry for the noise because my audio processing is not working quite well. So this is called a set builder method. Oh, let me not write this here. Instead of here, let me write it here. Set builder. We kind of kind of trying to move it like as fast as possible. So set builder method is here. You can let's take a really quick example. Let's take set of all positive integers less than 10. what I'm talking about is set of all positive integers, set of all, that's plus and v. I kind of like have a habit of writing these in this way: positive integers less than 10. So how we're gonna represent this? So let's take the entire set as e, and let's take a variable x. In maths we kind of use variables quite a lot, and this operator is called as such that. Okay, such that x, such that x is an even number or even integer. Because even because number itself is a set. I'm gonna explain it a little bit later. So integer less than 10. Got it? How gonna represent in rooster method? That can be represented as like 2, 4, 6, and 8. We're not talking about less than equals to, but less than, so up till 8. Okay, so that's how we represent sets here. That's how we kind of do it. But it's not necessary that all your sets are going to be always infinite. It could be like they're infinite, because like in maths infinite series are quite common. So it could be the list of natural number. I think it could be start with 0. I don't remember exactly, but gonna start with right here. And this dot notation is kind of important to show that it's kind of keep continuing over there. Then there could be a set of integers, all of the integers. So it could be like starting from like this, and -2, -1, 0, -1. You can like end like really quickly. It's a curly braces, so please don't mind. It's kind of like that. Now here's the thing. hmm okay, so let me explain another concept, which is like a subset. If you look like pay attention to the keyboard. What happened, man? Why my video is lagging? Is it fine now? I don't know, my video is kind of lagging. So sorry. So if you can look at the keyboard of your system itself, you can think of that there is these letters all together. Okay, then these are special keys, then these are integers, and these are function keys. What am I trying to tell you is that you can think of this as subsets. And what I mean that a set is your keyboard, then there is these subsets, that there is like alphabet key, then there is a set of special keys like brackets, decimal, angle brackets, anything like that. And there is function keys up top, then there is integer keys maybe on the side, maybe on the top. So these kind of make a set itself. And if we look and pay attention here, what is happening, man? What's not okay? Oh, now it's working fine. My bad. So if you can think of this in this way, and for example this is your keyboard, and this is actually called as Venn diagram. Okay, VENNDIAGRAM. Okay, so don't we get confused my writing. So you can think of like these are the function key, this is a set, another function keys, then these are like alphabet keys, then these are like special characters, and then there is a another set of like integers, numbers here. So that's kind of what happens is that think of this as key. So like these are integers or numbers, I'm going to represent n, special keys with s, you can take alphabets with a, function key with f. So this is how it is being represented, and like this a b c d is here, then like in number 1 2 3 4. So if you gonna tell that this is a subset, how you gonna tell it? So let me put this here. Got it. So for subset, how you're gonna tell is that n is a subset of k. That's a symbol of subset. Okay, and number 1 belongs to n. Got it? This is a very common representation when it comes to Venn diagram and all these things. So that's really important. Now there's one of the another, I think that's a very good concept to tell you, is something called a null set. And what it is, because see, we have seen subset and everything. Now there is something called a null set. It is represented with phi or maybe the empty braces. Got it? What does this mean? It's been like added like kind of in 19th century. It's not such an old concept, but it's been added to set theory, I think by a German mathematician. And here what happened with this is, you can think of this as, sometimes you have a set, you just have a set, you haven't been added anything yet to this set, so there must be something, and that's you need some operator to represent that this set contains nothing for as of now. and this value kind of represented kind of present every time, even if you know started entering the values here in this collection. So this thing is kind of known as null, is coming from the German language itself. So null is kind of, you know, becomes a really important part, and you gonna see this quite a lot, man, in programming. So that's a really important thing inside. How we're gonna see sometimes, you know, you were taking an you know that there is a you can think of this in this way, that you're gonna take a age from a user, and it's gonna be entered by user in a upcoming future event. Got it? And it's, since it hasn't been entered by user, but you know that you're gonna need the age for a calculation in a function. So you know you're gonna tell the computer that, hey computer, take this, and it's, oh, wait, not this, let me change it. You're gonna tell the computer, hey computer, there is a number, it's gonna be called as age, and once the user is gonna insert it, we're gonna enter it. You know, you just put this value here, or you can allocate a space for age. You're gonna pre-allocating like a, you know, reserving a space, kind of like in restaurant. So you're gonna tell that one more person is also coming, or one more, you know, thing is also coming. So you're gonna put the age like later on here. So that's what it is. Okay, so that's where, you know, null is kind of becomes a little bit important. And then there is something called see, you can also take an example of alphabets. No, A, B, C, and up to Z. So that's what the set of alphabets here. And how gonna, like, you're not sitting here to count everything here. So there is something called a size of a set, and it's represented by these two bars, and it's gonna be, oh god, 28. Why I'm typing 28 all the time? It's 26. Damn, 26. Okay, so the 26 is the, you know, the total number of, you know, elements in this set. Got it? Now, since we have talked about function, I think there is one more thing I should tell, is a power set. And what power set is represented by P, and let's take another example, B. And B is a set which contains 1, 2, and 3. Got it? So the power set of this function is gonna be a 5 empty, which is always presented. Then there is 1. What power set does is kind of convert all the elements, all the object into a subset, or kind of creates the set of themselves, you know. So subset is kind of thing which we saw a little bit earlier. So 2, 3, got it? Then 1 and 2 itself, then 2 and 3 itself, then 1 and 3 itself, then 1, 2, and 3 itself. Got it? So that's what a power set. It is always going to be in 2 raised to the power n, where n is the size of the set. Of set. It's really important concept. You're gonna see a lot this in programming. Got it? So this is a thing. Now coming to the function, there are like few things with function. I think let me explain what function is. You can think your computer device itself as a function. What I mean by that is that a function basically a kind of thing which takes a lot of input, produces an output, and that's what a computer is. It's kind of taking a lot of inputs and producing output. I don't know why is my video lagging. I don't know why. So you're having a lot of inputs, kind of feeding it with keyboard itself is a kind of think of, so this combo is a function. Then you send this you know, I'm sending this video to a server on YouTube, so that itself in kind of a big function, having a combination of a lot of function. And then it is sending this file to you. So what is happening here is that from one function you're sending an output to another function, which is acting as an input to another function. So that's what it's called. It's called a composition of a function. Composition. And what happened here is, so for example, you can have a function here, one function which is your for example my PC, and this function, let wait, let me show, kind of change, uh, let me present no draw here. So let me take this function. This is the function. My function is basically my PC. Now this function is outputting a video which is being fed into another function called G, which is YouTube server. YouTube. Okay. Got it? Now this function is producing an output, the file which is being sent to your device. Now take this as a function H, and you're watching it. this output. That's what composition of function is. So for example, your device is here. Let's take the example of YouTube server very quickly. So YouTube server is here. What is feeding? This function. And this entire thing is feeding your device. That's what composition of a function is. Got it? You're gonna see this in upcoming part of, you know, asymptotic analysis. We're gonna see it, and this is like quite important to understand. And function basically is like mapping. So if you remember that we had our kind of thing here. Did I do it? Yeah. So here, if you remember that PQRST on these statements are as a part of domain. Why? Because from here we are doing something, and this is a codomain. So what we are doing is we kind of, dealing with these things and kind of finding their mapping outside in some another set. And if we when we are finding their output and their related part in some another set, that's called a codomain, and that's a domain here. Okay. And this codomain and domain part I will explain a little bit later in, programming, when we're touching it. So here is another concept came into existence, which is one to one and on to. These two are like a little bit important. So in one to one, as you can see that p one to one means everything here from domain to codomain is gonna be have a one, corresponding output or the connection or mapping over there into the codomain. That's one to one. What is on to? Every part in the codomain is gonna be have a link into the domain. Not necessarily that every domain has a codomain, but in every object from codomain is mapped to a part in a domain, to an object to a domain. Let me explain this by a real world example of Aadhaar card. Aadhaar number system is kind of, social security number in in US. You can think of like that. So let's take here as a set of Aadhaar numbers, AADHEA, and here is a set of names of a person, because Aadhaar is associated to a person. So let's take example of name. So every Aadhaar number is gonna be associated to a name, to a person, a living person. Okay. But if you see that every name is always going to have an Aadhaar which came into existence, and there is always a pool of Aadhaar numbers which hasn't been assigned to anyone. Okay. This is a complete one side. This is a one side. So these pool is there, and there must be some person who hasn't been born yet. So once a person is born, a Aadhaar number from this pool is assigned. So what does this tell is that every name is going to have an Aadhaar number in the back, which is from codomain to domain. Okay. So that's a really important thing. That means it's a relation of onto. And that what is, once a person came into existence and Aadhaar is been assigned, that means every name is going to have an Aadhaar, and you can search about it. You can, if you have a name, a person is living or maybe now dead, and if an Aadhaar is assigned, which is I think by the way to every living person by when Aadhaar came into existence. So if you have name, you want to find Aadhaar, you can find it. If you have Aadhaar, you can find the name of a person. And that's what this is. That's what a function is. That's what a living part of this function is. Okay. Now there are two things. We have discussed composition. Composition is kind of, look like I have told you, like function. For example, if G is outputting something here, so it's kind of acting as an input here for F. Now there's something called function inverse. Okay. What I tell here, for example, if a function is kind of, you know, let's take this as hmm, function as finding name, maybe. Like let's take that this function maps only names. The inverse of this function, if we name this as G, is kind of finding out, Aadhaar numbers. Got it? So we can represent it like that. And don't confuse it with, 1 by F. That's a different thing. That's a different thing. But like F of inverse is kind of thing, like it's kind of converting, finding, reversibility. You can, like, if you have Aadhaar, you can find names. If you have name, you can find Aadhaar. So that's kind of inverse. Don't confuse, like it's a really simple concept. Inverse means you're reverting back. That's as simple as that. You're reverting from an output. You can like reach to an input from an output. That's kind of, in very simple terms. That's how you can understand this. Okay. Now I think this is the thing. There is an example I put in book. I've actually given. So very simple example. You can, think this example in this way where you can have like, for example, there is my friend Pushkal, and this is a name, and you can see like there is a correspondent Aadhaar number 1 2 3 4 5 6 7 8 9. It's a random dummy number, so don't try to find it. So for example, there could be a function. We can obtain this Aadhaar number. So for example, if we fed a name here, Pushkal, we can obtain a Aadhaar number in this function. This is a function, for example, used by government. So we can find, so this is a mapping. This function is kind of mapping. This is what mapping is. One, two, this is the same thing up to nine. Okay. For example, what if we have Aadhaar number? For example, if we went to for any service in India, usually what happens is that we, have put or give the operator our Aadhaar number so that they can validate us whether we are the, beneficiary or not. We could be, having it's kind of, identity, but not a, it's just an identity card. So we can benefit from the policies. So if you can think of this in reverse way or onto or anything or in composition of function if you want to see. So for example, it's kind of, if you tell this as f inverse, if you want to do it and assign it as g, so you can also represent this in, in a composition of function way, which is like feeding the, and if what it was outputting is 1 2 3 up to 9, and we can like get the name. I think that's more than enough in this video. Or is there anything else? I don't think so. There is like upcoming part where I think I've touched pretty much everything. That's very important. The function part, and I think set theory and how these things are. In computer, everything is a collection. So you have a physical part in your computer devices, in your mobile devices, where there is a part which is computing, kind of, having logic gates. So they are a collection. Then there are like collection of, memory, so where storage is being done, computation is being done. There is a collection in software itself, that where files are being stored, where these are pointers. These pointers, these kind of mapping thing is gonna be important, because in memory is important. We're gonna touch it. And once you understood memory, you're gonna understood like pretty much every concept quite easily in computer science. So the pointer is a concept where like points to a memory location, kind of, map. Like for example, you have mapped this name to this memory. These are like really important things. So that's why we touch this function, we touch the set theory, we kind of, have our understanding around it, because this why is really important for me. So I'm now able to think in a very different way. And I kind of ended this really quickly, but I think you got the idea. We're gonna see in asymptotic analysis, which is really important, because these everything, this all is gonna be like really, really, really important is in upcoming part. As you can see, roster method, etc. Did I discuss? I don't know. Oh, maybe I forgot. So, oh, you can see right here. So, or maybe I discussed it. I don't remember it. Maybe not. Oh, I forgot. So roster method is very simple. We kind of, see like this AEIOU, or maybe 1 2 3 4 5. Inside builder, I think I've discussed it like less than 10. Yeah, I think I did. Venn diagram, I've told you everything is there. Phi null, I think I've discussed that this value would be upcoming size. Then power set, this is 2 to the n, size of the set. Composition, I've told. Domain, codomain, we have discussed with Aadhaar and everything. I think pretty much everything is covered in the next part. So let's cover like very quickly your asymptotic analysis, because it's important. Then we're gonna touch C++ and Python. Like, oh, gonna do it like really fast. So